About Talend, right? Talend is an open source ETL tool, right? And the advantage it has is it's a code generator. So whatever the code we are developing in Talend will be converted into a Java code in the background, and you are installing only the Java code into your ETL box or somewhere, right? And it runs as a Java code. So you don't need an installation such that in case of the free version. So you can just create a job here and export it into a Java code and put it into the server. From there it can run as an independent job without any installation or anything. All the related packages will become along with that package itself. So that's how Talend works. So whatever we are creating in the code will be eventually converted into a Java code later, actually. So that's how it works. And how Hadoop helps Talend is, so say for example, say we saw that it's a code generator and it's a single Java thread, right? So in order to implement ETL tools will come with the problem of single thread cannot handle too much load, right? So that's where Hadoop helps Talend or any other ETL tool. So for a processing which needs a lot of run in parallel, we can submit the job to Hadoop actually. Talend submit a job to Hadoop, so that the job is become parallelized now, right? So by default, Hadoop runs all the jobs. If you run a job as a MapReduce, it runs in parallel. So that's how Talend uses Hadoop for its parallel processing. Okay. Say if you are extracting a very large table from the source to the source to target. If you have both of them in databases, usually it runs in it runs through an ETL layer in Talend, which is a single-threaded application. Instead, we can have have Hadoop in the middle, which actually process the data or any other transformation you are trying to do in a parallel processing as a MapReduce job. So that's the whole idea, and that's a whole idea where the industry also trying to move towards, where you want to harness the power of Hadoop inside a common ETL tool. So the ETL tool will just become a designer where you can easily develop MapReduce jobs. So in the same way, how Talend helps Hadoop is Hive and Pig has generalized the MapReduce in a very long way, right? So we no longer need to write hardcore Java programs to achieve something very simple, or hardcore streaming program to do some data process. Instead, we can write a very simple Hive query or Pig script to do these jobs. Talend goes little further above into the stack, where it gives a visual programming, just like any other ETL tool for MapReduce. Like we can develop a whole Pig script within it graphically without doing any coding in the table, any coding inside the Hadoop layer. So it gives a lot of flexibility to us to write, to create and implement MapReduce jobs on the fly. That's the biggest advantage we get out of Talend. How Talend actually helps Hadoop. So we'll move forward. I just gave a very brief intro how these two work together. Right? Hadoop and Talend complement each other in their technology. Right? So how ETL tools connect to Hadoop is so the ETL tool should reside in somewhere, right? So say for example you have a node in the whole cluster, or a separate node which has connectivity to the name node, the job tracker, and the Hive installed locally in that machine, Pig installed in that machine in the client. Assume that everything is there in that ETL box. You can call it as an extractor box, where it works. It just acts as a separate ETL node connected to which has connectivity to the existing Hadoop cluster. So you can run your ETL jobs in that node, particular node, and run your Hadoop jobs. For streaming jobs, if you are writing a streaming jobs in the ETL tool, you can submit as a normal MapReduce jobs calling in the command line itself. So that is not much change in the streaming side. But we will concentrate mostly on Hive and Pig in today's session. Hive is using the thrift server to connect to the actual the cluster. And Pig is, Pig will automatically, in case if you are developing a Pig script in the ETL in Talend, it will submit as a MapReduce job to the job tracker itself. And then later it keeps track of that MapReduce job. So first we will go through like how we can start a thrift server and what is a thrift server. So thrift server is nothing but first we'll start with the Hive, right, and then we'll go over Pig later. Say for example you can, so this is my console. So what I'm running now is I just installed, can you see my window? We start a thrift service. Thrift service is nothing but just like a command line entry for Hive. So you guys have worked with the command line interface of Hive or Hue, right? So if you enter a Hive command, it just opens a command line window where you can run your code, right? So what thrift service does is it just opens up a port in that box, in that box for any other and listens to that port for any other query submission. So in this case, we have opened in the current console itself where we open the box for further querying, right? Instead, what we are going to do is start it as a server. This is a command. So Hive service, Hive server. This service starts listening for any Hive queries in this command, in a particular port. The default port is 10,000. So what it does is when I give this service and starts this Hive server is a service which is a program which actually starts this thrift server. So you have to connect to a Hive through this designated port and machine. Say for example in a cluster, you have a cluster and you have an extractor ETL node where you have Hive installed, and that node should have connectivity, as discussed already, should have connectivity to all the cluster nodes. When you start this thrift server in the extractor node, right, it channels all the Hive queries to this extractor node and runs inside the cluster. So it's just like a listener for the Hive CLI, or you can just a listener for the Hive to CLI. Okay. So I'm starting this thrift server. So it mentions okay thrift server start. If you check this, we can run a command lsof. So it just scans through all the port whether you can check if it is listening. So the 10,000 port is listening now. The default is 10,000. You can also start a thrift server in a designated port. If you want different port for different projects, you can start as many thrift processes as possible in the extractor node, so that no project will clash actually. So we started the thrift server. And whenever you submit the job, you need to configure your job into this thrift server. Okay, and internally it manages this. In the Hive itself manages submitting the MapReduce and all the stuff internally. So this is a very key concept here. And I want to mention like I'm running a DerbyDB metastore. It's not a MySQL or database based metastore. What is the problem with the DerbyDB is you cannot have concurrent connections for to the same Hive metastore. What that means is you cannot have multiple connection, a CLI open and also a thrift connection to the same metastore. So that's not possible. That's a problem with using the default DB for your metastore.